So a question that might have come up in your mind is, what do I do if I don't have all of the angles in a triangle and I'm trying to completely solve the triangle? So today we're going to talk about inverse trig and being able to just use the sides to determine certain angles. So what we've worked with before is just regular trigonometry, in that we see sine, cosine, and tangent. And in this case, we will need an angle measure as our input, or the thing that we need to know, so that we can find the ratio or measurement of sides. So for example, in this triangle on the right, I might say, okay, well, I know that I'm going to look at this angle 53.13 degrees, and the sine of that angle is going to be the opposite over hypotenuse, which is 8/10, and I can reduce that to 4/5. So the sine of 53.13 degrees should equal 4/5. Likewise, I could do the cosine of that angle, 53.13 degrees, and cosine is going to be adjacent over hypotenuse, which is 3/5. So I'm really just saying what I know about this triangle. Tangent of that 53.13 degrees would be opposite 8 over adjacent 6, or 4/3. So the new relationships that we're going to look at today is what happens if I want to get back to the angle. So in other words, this time I know the measurement of the sides, and I want to solve for the angle measure. We're going to just look at this relationship first, and then I'll show you how to solve that. So again, in that right triangle that I see on the right, if I want to find the sine, the inverse sine of the relationship, so sine of this angle would be opposite over hypotenuse, which is really 8/10, but I went ahead and reduced that to 4/5. If I plug that into my calculator, now notice on my calculator right behind the sine button is this sine inverse button, and if I do that, it's going to spit out the 53.13 degrees. Arc sine is just a different way of writing the inverse of sine, so again, arc sine of 4/5 is going to be that 53.13 degrees. In relation to that angle, cosine would be adjacent over hypotenuse, which is 6/10, which really reduces to 3/5. If I do the inverse cosine of 3/5, I'm going to get that 53.13 degrees. Likewise, arc cosine is just a different way of writing that. Arc cosine of 3/5 is going to be 53.13 degrees. And then tangent is opposite over adjacent, which is 8/6, reduced is 4/3. Inverse tangent of 4/3 should still be that 53.13 degrees. Likewise, arc tangent of 4/3 is 53.13 degrees. So let's really look specifically at how that's going to help us solve problems. So on the first example, it says find the measure of angle D. Well, you notice on angle D, in relation to angle D, I know adjacent and the hypotenuse. Adjacent over hypotenuse is cosine. I don't know the angle, so I'm going to say cosine of angle D equals adjacent over hypotenuse, 4/10. If I reduce that, that would be the cosine of D is 2/5. So I'm going to go ahead and plug that into my calculator. So 2 divided by 5, and it gives me the decimal 0.4. So cosine of D equals 0.4. Now to undo that, or get back to the angle, I'm technically going to take the inverse cosine of both sides. So I'm going to do the inverse cosine of 0.4, and it will give me the answer where angle D is 66.42 degrees. So I'm just using that inverse button to get back to the angle. So let's look at a few of the other examples. The first one, I'm going to set up an equation first. In this one I want x, so I'm going to not use inverse right now because I already know what the angle is. So this would be, in relation to the angle, 25-degree angle, I know, or I want to know opposite over hypotenuse. Opposite over hypotenuse is sine, so we'll go sine of 25 degrees equals opposite over hypotenuse. And then I'm just going to solve. So the sine of 25 degrees is 0.4226 will equal x over 14. Multiply both sides by 14. And I get that x equals 5.92. Now in the next problem, I'm going to set it up again using a trig function. I know that the angle is 28, so in relation to the 28-degree angle, I know opposite. So opposite over hypotenuse is going to be sine of 28 degrees equals opposite over hypotenuse. I'll find the sine of 28 degrees. It's 0.4695 equals 17 over x. This time I'm going to want to multiply both sides by x. So I have 0.4695 x equals 17, and then I'll divide that 17 divided by 0.4695. This time I have x equals 36.21. And then finally the last question. I don't know the angle this time, so I'm going to say, in relation to x, what do I know? I know opposite over hypotenuse, which is still sine. So sine of x equals 21 over 40. So in this case, sine of x, I'm going to go ahead and divide that out. 21 divided by 40 is 0.525. And then I want the inverse sine of that answer to go back to my angle. So x equals 31.67 degrees. So now you're going to have several different scenarios that you're going to have to problem solve to see what you're solving for and whether you're going to use regular trig functions or inverse trig functions.